Hi, it's Carly McAvoy. I want to explain a problem to you where you're not just talking about one person, but many people, and how that is using the standard deviation of the mean, and also using your TI-84 calculator when your mean is not 0, your standard deviation is not 1, and your n isn't 1. It works the same way, but I want to show you an example with that. So in this example, the height of men is normally distributed with 69.1 inches for the mean and 2.9 inches for a standard deviation. If one man is randomly selected from the population, what's the probability that he will be more than 71 inches tall? If we're choosing one person, then we use the mean that we're given, that's the 69.1. We also use the standard deviation that we were given, that's 2.9, and we find the probability of what's the probability that he's greater than 71 inches tall. Of course, if we pick one person, then we could just randomly pick one really tall person or one really short person, so there's a pretty good probability that they won't fall right close to our mean. I have these pictures in here from StatCrunch. I don't think that you have StatCrunch available necessarily. I just wanted to show you so you could visualize. This is what you get if your mean is 69.1 right here and your standard deviation is 2.9. The probability that you would get somebody who's greater than 71 inches tall is about 25.6 or 26%. How do you do that on the calculator? You're just going to turn your calculator on. This is a TI-84 Plus again, and then you're going to hit second function in the VARS. Above that says distribution. That's what you want. You want the normal CDF, which is the second button down. So we're going to hit 2. And then we want to put in our lower and our upper bounds. And our lower bound here is 71 because that's what we're asking. What's the chances that he's 71 or greater? Our upper bound is 1E99. How you put that in is 1, and then second function with that over above the comma, EE, and then 99. Basically, that takes you out to infinity. And then your standard deviation, your mean is 69.1, and your standard deviation is 2.9. So then you're just going to hit enter twice, and that loads it into the computer, and then hit enter one more time, and you get that 25.62 amount. So that's different than if we were asking about more than one person. So let's see how that looks. If I come back and look at our example again, the second part says if 19 men are randomly selected from the population, what's the probability that the mean of their heights will be more than 71 inches? So this is really the point of this video, is to show you the difference here. The difference is that if we have 19 people, we have to take our standard deviation, that was 2.9, and divide by the square root of the n, which in this case is 19. We said if we pick 19 men. That changes our standard deviation. It should make sense to you that you could randomly find one person who's very different height-wise, but finding 19 people that all average to be different height, that's should be really different, right? And so this particular example, you can see the red over here is barely there because it's a really small percent, 0.2%. And so I would go back and do that same thing again with my calculator, and that is second function distribution, go down, just hit 2, enter, and then we have the lower 71, the upper is infinity, and the difference here is that we're going to enter our new standard deviation, which was the standard deviation divided by the square root of 19, because n was 19 in this case, and that gave us 0.67. Hit enter twice. That enters it into the computer. Hit enter one more time, and you'll get that really small percentage that we saw and we would expect to see with a problem like this. If you just want to know how to do this on your calculator, you could be done. I just want to show you a couple of other things. The part C said if 19 men are selected, what's the probability that their height will be less than 68 inches? So just visualizing that, we're looking at what's the probability that you're going to be over here that is less than 68 when the average is 69.1. And you can see that with 19 people, that comes out to be about 5%. You're going to find that you're going to do that the same way. That's actually 2 there. You're going to find that using the same steps. that you did before. And you could also do this where you're just looking between what's the probability that this problem said, what if 19 are selected, what's the probability that their height is between 68 and 70 inches. So down here, we would do that a little differently if we put it into the calculator, and that would look like this. We would have second function distribution, and then 2, or go down to 2 and hit enter. And then our lower is 68, and our upper is 70. So we're actually asking about what are these two people, how between these two values, how many people fall in there. But our mean 69.1 and our standard deviation 0.67 are going to stay the same. I'm going to hit enter to put that in there, and then I'm going to get that 86% of the people would fall within those two ranges because that center's right around the mean. All right, have a fantastic day, and I'll see you next time.